humans. We're going to do 7.1a today. We're going to be talking about systems of equations. Our objectives are that we are going to solve systems of equations using substitution and graphing. So we're just going to jump right in with some examples. Our first example says solve by substitution. And this is a review from previous math classes, but for us it's just going to be a nice way to start this particular chapter. So we have 2x plus y is equal to 5, and 3x minus 2y is equal to 4. So when I start by doing substitution, I have to solve one of these two equations for one of the variables. So I'm going to choose to start with this one because the y is by itself. So I'm going to get y is equal to 5 minus 2x. Then I'm going to take this and I'm going to substitute it into the other equation. So I'm going to get 3x minus 2 times 5 minus 2x is equal to 4. Then I'm going to simplify this math. I get 3x minus 10 plus 4x is equal to 4. 3 plus 4, 7x is equal to 4 plus 10 is 14, and I get x is equal to 2, or 14 divided by 7. Once I've solved for x, then I can go back and solve for y. So this is going to be 5 minus 2 times 2. 5 minus 4 is 1. So then when I report, I'm going to report as an ordered pair. We found our x value to be 2 and our y value to be 1. So the preference for reporting is that you're going to always report in an ordered pair. All right, our next example, example 2, we're going to solve by graphing, which means you're going to need your grapher. So we're going to solve graphically. And I'm going to do the same system. So I'm going to do the 2x plus y is equal to 5, and 3x minus 2y is equal to 4. To be able to solve graphically, that means that I have to solve both equations for y. So I'm going to get y is equal to 5 minus 2x. I don't even have to rearrange it. In this one, I get a negative 2y is 4 minus 3x. Divide both sides by a negative 2, and I get y is 4 divided by a negative 2, and then minus 3x divided by a negative 2, which is a negative 2 plus 3 halves x. So then what I'm going to do is get out my handy dandy grapher. I'm going to go back to and clear what's there. So the first equation was 5 minus 2x. The second equation is a negative 2 plus 3 divided by 2. I could just enter it as 3 divided by 2x, or I could do the decimal equivalent. It doesn't matter. And I'm going to do a zoom 6. There's the first line. There's the second line. So then I do second calculate 5 for intersect. I'm just going to get semi-close with the first one, semi-close with the second one, hit enter twice, and notice that it shows you that your solution, xy, is going to be 2, 1. But remember, if I am using my grapher, then my responsibility is to sketch my graph, and I would sketch the first one, 5 minus 2x, which was this line, and then I had another point of intersection, and it's kind of a crappy graph, but then I would label that point 2, 1. So remember, anytime you use your grapher and you solve something graphically, the expectation is that you will show your work. All right, the next example we're going to do the same problem algebraically and graphically just to illustrate a point. So for example 3, it says solve, and we're going to do it algebraically and graphically. All right, our system is going to be a negative x plus y is equal to 4, and x squared plus y is equal to 3. So the first thing that I'm going to do is I'm going to do the algebra first, because I love algebra. So I'm going to solve the first equation for y, and I'm going to get y is equal to 4 plus x. and then I'm going to take that and substitute it into the next equation. So when I do that, I get x squared plus, here's my y, 4 plus x is equal to 3. I'm going to combine like terms, so I have x squared plus x, 4 minus 3 is a positive 1, is equal to 0. And it looks like this is going to be difficult to factor, so I'm going to invoke my cool little calculator, and I'm going to do my quadratic program. So I'm going to do program quadratic and enter. My a is 1, b is 1, c is 1. And if you'll notice on my cool little grapher, I get imaginary solutions. And so I'm just going to write that x is equal to a negative 1/2 plus or minus 0.866i, because those are the solutions. Alrighty. The interesting happens when I graph. So now I'm going to do the graphic solution. So when I graph my two equations, so I'm going to go to my y equals and I'm going to clear what's there. And I'm going to graph y is equal to, the first one was 4 plus x. And then my second one was 3 minus x squared. And I'm going to do a zoom 6. There's the first line. There's the second line. So let me pull it up and see if you can see it a little bit better. Notice that those 2 points don't intersect. So if I were doing this graphically, I would say that there is no solution because there is no intersection. And then remember, it's my responsibility to show that there's the first graph and then here's the parabola. And just because we've been talking about it, I'm going to circle it and say no solution because there is no point of intersection. Alrighty. The next example that we're going to do, example number 4, we're going to do graphically. So I'm going to put solve graphically. Your grapher is a great way to solve equations, especially if the math is difficult. So let's say I have x squared plus y squared is equal to 25, and x minus 8 quantity squared plus y squared is equal to 41. So the interesting thing to notice is that both the x and the y are squared in both equations. So this is actually, both of these are equations of circles. So I'm going to have a circle. This one is going to have a radius of 5 and it's going to be centered at the origin. This one has a radius of the square root of 41 and it's going to be centered at 8 and 1. Okay? Oop, I lied. This is, you're right. Sorry, whew, brain fart. 0, 0. Alrighty, so that's what my graph is going to look like. So the first thing that I'm going to do is I'm going to solve the first equation. So I'm going to get y squared is equal to 25 minus x squared. I have to solve for y to put it in my calculator, but when I do, I'm going to get plus or minus the square root of 25 minus x squared. And remember, this radical doesn't reduce because it's underneath the radical. When I enter this into my y equals, I have to enter the positive root, so I hit 25 minus x squared, and then I have to enter the negative root, second square root 25 minus x squared. So I can't enter plus or minus on the same line in your grapher. You have to enter it separately. So I'm just going to do it like this. Okay, and then I'm going to save that for a moment. So I'm going to move it out of the way. The second equation is y squared is equal to 41 minus x minus 8 squared. When I solve for y, I get plus or minus the square root of 41 minus x minus 8 squared. And I'm just going to put it in my calculator like that. So I'm going to go down to the third equation. I'm going to enter the positive root, 41 minus x minus 8 quantity squared, except I forgot the radical, sad day. So I'm going to delete. So I'm going to do it again, second square root, 41 minus x minus 8 quantity squared. and then I'm going to enter the negative root, 41 minus x minus 8 quantity squared, and then I'm going to do a zoom 6. So there's the first circle, and then there is going to be the second circle. So I want to talk about a couple of things on your graph as I bring this up so you can see. For starters, notice that the x-axis and the y-axis aren't the same, which is why our circle looks like a square. So I could do a zoom 5 and change my axes to be square axes, and then it will actually look like circles. The other thing to notice is right here, it appears that there is a gap at the x-axis. That is not true. We've talked about that before. That's called graph or failure. It just doesn't have the graphic capabilities to show you that it actually crosses those axes. So don't think that it is two complete sets of parabolas. That's not true. It is a circle, and there is no gap at the axis. So now if I want to find those points of intersection, I can do second calculate 5 for intersect. Notice where my cursor is. It's on the top blue circle, and I'm just going to get closer to that point of intersection, hit enter. Notice then that this one pops down here. This was the second equation that we entered, but that's not the one that I want. So I'm going to use my down arrow, and notice right at the top, now I'm on the third equation that I entered. I'm going to get closer to the point of intersection, enter, enter, and I get x is equal to 3 and y is 4. Sorry, I'm just going to write that as 3, 4. And then I'm going to go do the second half of the circle, 5 intersect. I'm going to go to, notice I'm on the red circle, there's my equation. I'm going to move away just a little, hit enter. And notice it popped right back to the black one, but I don't want the black one, I want the purple one. So I'm going to go down to that purple equation, enter, enter, and it tells me that that other point of intersection is 3, negative 4. And then again, my responsibility is to show the two circles. So here was the first circle centered at the origin. Here was the second circle. That point of intersection is 3, 4. And this point of intersection was 3, negative 4. So there are my two solutions. And then if I were reporting correctly, I would say xy is equal to, and you could do 3 plus or minus 4 and just write it as one equation. Alrighty, that is it for today. I will see you soon.